So we have seen this earlier, which is the capacity factor. So if the factor is greater than 1, then more resource block tends to be allocated to the user with higher SINR. So we have seen that earlier. So if the factor is 1, which is the default setting, then the resource block tends to be allocated fair. And if the factor is smaller than 1, then more resource block tends to be allocated to the users with a lower SINR. So to make sure that the QoS of the service of the users are guaranteed, then the GBR service always has a higher priority compared to non-GBR services if both services are running simultaneously. So for GBR service, since the 3GPP has defined the packet error loss rate and the packet delay budget, then the scheduler always has to make sure that the packet error loss rate and the packet delay budget, which is defined in the 3GPP, they must be fulfilled for GBR services. As for non-GBR barrier, the scheduler only has to make sure the packet error loss rate. As for the delay or even the service rate for non-GBR barrier, then a best effort policy is being used. So right after the scheduling priority of the user has been determined, the InnoB has to select the appropriate modulation and coding scheme. So in the steps to select the modulation and coding scheme, the InnoB starts from obtaining the index for transport block size. So the InnoB receives the CQI, which is sent by the user, and the InnoB will proceed to adjust the CQI according to CQI adjustment algorithm. So based on the adjusted CQI, then the InnoB is going to obtain the index for the maximum, the largest transport block size, which is supported according to the reported CQI. So we can have a look here if the frequency diversity scheduling is used, where the number of the resource block allocated for the users are continuous, then the user has to send full band CQI reports. But if we are using frequency selective scheduling, means the resource block allocated for the user might not be continuous, then the user has to send sub-band CQI report. So if the CQI adjustment algorithm is enabled, then the InnoB has to adjust the CQI reported by the user. As compared, the InnoB will actually monitor the block error rate and to compare it with the block error rate target. And then if the block error rate is greater than the target, then the CQI will be reduced. And so based on the reported CQI and the adjusted CQI, InnoB select the appropriate modulation and coding scheme. So the InnoB select the modulation coding scheme according to the mapping from the index of the transport block size to the index of the modulation and coding scheme. So that means the InnoB has selected the maximum transport block size earlier based on the CQI, and based on the selected transport block size, then the InnoB has to select the appropriate modulation and coding scheme in order to send or in order to support the selected transport block size. For the handover and in the user, InnoB use a fixed modulation and coding scheme to ensure the quality until the InnoB receive a valid CQI report. So it means for a user who has just performed handover to the new cell, then the new cell use a fixed modulation coding scheme until the InnoB receives the new CQI report which is sent by the user. So this is the classification of the CQI report. There are two types of it could be a periodical report where the user is reporting the CQI by sending it over PUCCH channel, and the user is reporting that according to the period which has been set by the RRC. The second type of the CQI reporting is called a periodical, where there's no timer, the user only send the CQI report as per prompt. Then the user is actually sent by a channel which is called PUSCH. So usually this is triggered by the init B. The init B send a PDCCH with at the same time allocate the PUSCH resource for the user so that the user will be able to use the PUSCH to send the periodical CQI report. Now, as for the report bandwidth, there are two types of the CQI reports. The first one is called wideband CQI, where the user report one value which is going to reflect the downlink quality for the whole band. Second type of the report is called subband CQI report, where the downlink quality for some subbands will be sent, where the whole band is going to be divided into few subbands, and the user has to report the respective downlink quality for each subband. So that is called subband CQI. So as we have mentioned earlier, that the CQI which is reported by the user could be adjusted because the user always report the CQI value which is reported by the user. Sometimes it does not reflect the actual channel quality. So this is actually because the CQI reporting period is far greater than the scheduling period. So sometimes the user has been sending the CQI report which has been quite long time ago, and that is not so accurate in terms of scheduling. Or sometimes the CQI report might be delayed due to the transmission delay and the process capability. So if the CQI reporting delay is longer than the channel coherence time, then the CQI reported by the user is not consistent with the real channel quality at that time. So if we want to turn on that, we have to turn on the CQI adjustment algo switch. So if we have turned on that, init B adjusts the reported CQI based on the initial block error rate target, where the init B measure the initial block error rate and compare it with the initial block error rate target. So if the initial block error rate is greater than the target, then the init B reduce the value of the reported CQI. Then the block error rate target, it could be adjusted as well. If the downlink variable initial block error rate target switch is off, then the block error rate target is set to be 10%. If it has been set to be on, then the 30% of the block error rate target will be used. So based on the CQI which is sent by the user and adjusted, then the init B select the maximum transport block size for the user and then map to the modulation and coding scheme. So after that, the init B has to decide how many resource block to be allocated for the user. So that could be, that is PDSCH, because this is for downlink. So the scheduler has to obtain the amount of the data to be scheduled. So then based on the real amount of the data to be scheduled, then the init B decide the real transport block size. Because just now the CQI which has been adjusted earlier, that is to determine the maximum transport block size. But a real transport block size will be selected based on the real amount of the data to be scheduled. Then based on the selected transport block size, then init B estimate the exact number of the resource block to be used. Then based on the estimated resource block number and the remaining power, init B decide the last number of the resource block. So we have mentioned before there are two types of the scheduling, which it could be frequency diversity or frequency selective. For frequency diversity scheduling, init B allocates all of the resource block from the lower end to the high end of the frequency band. So the resource block allocated for the users are continuous, and that is based on full band CQI. If frequency selective scheduling is used, means the user is required to report subband CQI. The resource block allocated for the user could be not continuous. So this is the diagram of the frequency selective scheduling, where we can see that UE1 is being allocated resource block group of 12, and here 13, and user 2 is being allocated a resource block at number 10 here and 8 here. So the resource block allocated for the user, they are not continuous. This is frequency selective scheduling, and that requires the user to send subband CQI. As to compare with the frequency selective scheduling, we are looking at frequency diversity scheduling, where the resource block allocated for the users are continuous. So we can see that frequency diversity scheduling is more simple, as the number of the resource block allocated for the user is allocated right from the lower end to continuous, and the user only needs to send a wideband CQI. But frequency selective scheduling is more effective, as the user will be allocated the resource block which is most beneficial to the users according to the subband CQI reported. So that's all for the downlink scheduling, and we are going to have a look on the uplink scheduling in the next